Hello, guys. Welcome back to the session number 4 of the series. Previously, we discussed the construction and working of limit switch. This guy right here. Let me give you a quick recap before we move on to our original topic. Now, limit switches are contact-based sensor, and they provide output signal if and only if the object to be detected makes physical contact with the sensing element of the limit switch, which is also known as its arm, right? Now, after the contact, the arm has to travel a certain distance before it goes into the actuated state, and then it will generate an output signal. But what exactly is this output signal? The limit switch is equipped with the NO or NC contacts internally or in some cases externally. We provide power at one end of these contacts, and we receive this power from the other end in the form of a signal, right? Now, depending on the scenario, you should use NO technologies or NC technology. When you are using the limit switch as a safety element, as a safety device, you want to stop a critical operation, go ahead and use the NC terminal. If you are using the limit switch for triggering something, for giving the pulses, for counting, for checking the presence, then it is advisable to use the NO contact. Why is this? We are going to cover this when we discuss the industrial logics and the PLC programming. For now, let's move on to the original topic of this session, which is proximity switches. This is going to be a brief overview of the technologies involved, and in the next session, we are going to dive deeper into these individual technologies. Let's begin. The proximity switches, they generate their own surrounding. Now, it can be a spherical field, it can be a straight beam, or it can be a expanding wave. The catch is if the object infiltrates this surrounding area, then the sensor's electronic circuit detects this change, and after a certain threshold, it generates an output signal. If this is not making sense right now, don't worry. We are going to dive deeper into these technologies. For now, just remember the whole point of proximity switches is to have contactless sensing with little or no moving parts. We want this in an industrial setting because we want operational durability and longevity in the sensor's life. Now, in this series, we are going to discuss these four technologies primarily. There are other technologies for example, infrared or reed switches. However, for the sake of simplicity, I have kept it to four. We are going to discuss reed switch in the pneumatic section of the series. Now, the four technologies that we are going to discuss are capacitive, inductive, photoelectric, and ultrasonic. Also, please note their symbol, their schematics. They are very essential if you are going to read the electrical diagrams. Also, let me tell you the generalized symbol for a proximity switch. It is something like this. A N or NC switch encompassed by a field. This is the generalized symbol for a proximity switch. But let's take a moment. Let us discuss what exactly is proximity. Let's look at nature for a better understanding. Now, spiderweb is a perfect example for this scenario. This 2D shape is the proximity of the spider. Now, if the prey accidentally touches the web anywhere, it generates a signal, and the spider detects this signal and it pounces immediately. So, we need technologies that can mimic the spider web. The most obvious is going to be a laser light, or in the case of photoelectric sensor, they generate a beam of light, and if any object touches this beam, it is going to generate a signal. The less obvious technologies are the electrostatic field used by the capacitive proximity sensor. It uses parallel plate capacitance and which generates an electric field. And if the object enters this field, this is detected as a change and the capacitive sensor gives the signal. This is the inductive sensor. Now, instead of electrostatic field, it generates electromagnetic field. But there is a catch: electromagnetic field does not affect all the objects. So this is particular to metal objects only. The last one uses acoustics. These are ultrasonic sensor. They use powerful beams of sound waves, and they travel in the air and they strike the object and travel back. If this is detected, and in some cases it is obstructed, so this will tell you if the object is present or not. So that's it for now. In the next upcoming sessions, we are going to discuss these individual technologies in detail. So stick around and thank you so much.